Hey there, we're going to do today molarity and dilution equations. I've put the equation on the top of page 11 for molarity. Molarity is moles divided by liters. Okay, so let's start with number 5. What's the molarity of a 1.5 liter solution that contains half a mole of magnesium chloride? Well, this one's pretty easy. I always write out what my variables are, what I have and what I need. So I'm looking for molarity. Okay, I don't know what it is. What is the molarity? That's my volume. So molarity, I need moles and I need volume. Okay, my volume is 1.5 liters, 1.5 liters. It says that I have half a mole of magnesium chloride. Okay, so that is the number of moles, 0.50 moles. Okay, straightforward equation. Molarity is moles over liters. Plug in my variables into the formula. 0.50 moles and 1.50 liters. Okay, so 0.5 divided by 1.50 gives me 0.33. Hey, sorry about that. I wonder if did you see that? Somebody came in. You probably didn't see that, but you may have heard it. Anyway, so I had to pause you for a minute. So when I divide 0.5 by 1.50, I get 0.33. Looks like 2 sig figs is my limit here. So 0.33, yes, rounds to 0.33 molar. Okay. Next question, what's the molarity? So I'm looking for molarity again. What's the molarity of a solution prepared by dissolving 80 grams of sodium hydroxide in enough water to make 1 liter? There's my volume. Okay, but that's not my moles, is it? No, it's not. It's grams. Can I get moles from grams? You betcha I can if I divide by the molar mass of sodium hydroxide first. So I'll use a space up here. 80 grams of sodium hydroxide, and you just need to convert it into moles, is it? So just go down grams of sodium hydroxide. And recall that 1 mole equals molar mass in grams. All right? So I need to find the molar mass of this in 1 mole of this. So I look on my periodic table. The molar mass of sodium is 22.990, and I only have 1 of those, plus the mass of oxygen, 15.999, plus the mass of hydrogen, 1.008. That is the molar mass of sodium hydroxide, 39.997. Okay. Grams of sodium hydroxide cancel, and I'm left with moles. So 80 times 1 is 80, divided by 39.997, which is about 2. Yeah, it's close enough to 2 to make it 2. So 2.000 moles. So I now have moles. So molarity is my question. I don't know what that is. Moles, 2.00. And volume is 1 liter. So molarity is moles over liters. Moles is 2 divided by 1. The molarity is 2. How many sig figs? Well, there's 3 sig figs there, so I'm going to go with 3. 2.000. Oh, 3 sig figs, big dummy. There we go. Erase a 0. 2.00 molar. Okay, that's my answer. Let's go to the next page. These are dilutions, and there's my formula for dilution. Kind of messy. M1V1 equals M2V2. M is molarity, V is volume, and that can be in either liters or milliliters, although it just needs to be the same. If one is milliliters, the other one has to be milliliters. So my first problem says how many milliliters of initial solution of 4 molar Ki would you need to prepare 250 milliliters of 0.60 molar Ki. So I know I'm going to have M1, V1, M2, V2. So I'm listing my variables there. M1, my initial molarity is 4. And it says how many milliliters of initial solution. So there, I know that my volume, my initial volume is what I'm looking for. M2, my other molarity, 0.760 molar. And my volume, 250 milliliters. M1 V1 equals M2 V2. M1 is 4. V2, I don't know what that is, so I'm just going to use V2. M2, my second molarity is 0.760. And my second volume is 250 milliliters. So I'm going to multiply these two together. 0.760 times 250. You can't see that. Gives me 190. So 4 times V2 equals 190. Need to get V2 by itself, so divide both sides by 4. My V2 is 190 divided by 4, 47.5. Well, it looks like I can have 3 sig figs, so that's perfect. 47.5 milliliters. Okay. Number 6. How many liters? I'm looking for a volume. How many liters of 15 molar sodium nitrate are needed to make 225 milliliters of a 0.1 molar solution? So I know I'll need M1, V1, M2, V2. My initial molarity, 15 molar. My initial volume is, that's again, it's my X. Just so happens, just picked it randomly. M2, 0.100 molar. And my V2, 225 milliliters. Formula, M1V1 equals M2V2. Initial molarity is 15 times V1 equals M2.100 times V2, 225. So I'll do the same thing actually. Let's see if we can get it all in there. Yep, I sure can. 0.100 times 225. Okay, this is 22.5. 15 times V1 equals 22.5. Divide both sides by 15. V1 equals, let's see, divided by 15, 1.5. So how many sig figs can I have? 2. 1.5 milliliters. That's my final volume. Okay, if you need to rewind and watch again, rewind and watch again.